Jason Dietz is a pavement and materials engineer with the Federal Highway Administration Resource Center in Denver, Colorado, and has been with FHWA for 25 years. He's provided preservation training to agencies nationally. Next up is Jason Dietz, and he's going to discuss thin overlays.
Well, welcome everybody. Hi everyone, and thank you for joining us for this webinar today. We'll be discussing thin asphalt overlays, and we'll be highlighting equipment and placement. Again, my name is Jason Dietz. I'm with the Federal Highway Administration, the Resource Center, and I'd like to start off by thanking Judy and the National Center of Pavement Preservation for reaching out for me for this presentation today. I also would like to point out that there's an NCHRP Synthesis 464 on thin asphalt concrete overlays, as well as an FHWA tech brief that was published in June of 2019 on the use of thin asphalt overlays for pavement preservation. One of the nice things about asphalt is that the distress is confined to the surface. It can simply be milled out and overlaid. There are a number of benefits to milling. A few of the ones are listed here. One uses cores to help you determine the proper milling depth, and that's very important. Milling can help you restore smoothness. It can also help restore the cross slope for proper drainage. When it comes to curb and gutter sections, to maintain that proper curb exposure. It also can allow to maintain bridge clearances as opposed to shrinking the clearances by a few inches each of the new overlays. It can also help alleviate any drainage issues and create a nice texture surface that helps grab into the new overlay and pavement to prevent slippage. Mill depth enough to remove the entire distress layer. One thing you want to do is to make sure the depth of the milling is not right at the interface. Since asphalt thickness is not 100% uniform 100% of the time, trying to mill to the right lift interface can often leave scabs, as shown in the photo here, which can delaminate and cause some problems. We recommend that you mill down a bit further into the structural sound surface to avoid any issue. The use of leveling cores on the uneven surfaces, similar to what we do on traditional mixes. If you have an uneven surface that you don't want to mill, you can use a 4.75 millimeter mix or a sand mix to level it up. These pictures are some examples that I've seen over the years and wanted to share with you. On the bottom right-hand corner shows one where an agency wants to continue the use of a 12.5 millimeter, and as you can see, the coarse aggregate gets drugged under the screed. And then on the upper left-hand corner is an agency using a sand asphalt mix. One of the things with this kind of mix is that it clearly shows where you need to use the screed adjustments, and that's something to keep in mind. Furthermore, as most agencies are going to more overnight construction, climatic considerations for thin asphalt overlays are important. With that in mind, paving thin lifts at nighttime could present a challenge. Because of the cooler temperatures and often higher humidities, it takes the tack coat longer to break. And of course, the cooler temperatures reduce the time available for proper compaction. And for night construction, there can be some visible issues as well, and safety becomes a major issue. Proper tack is critical for thin lift overlays. As critical as obtaining a proper tack for typical asphalt constructions, it's even more so for thin asphalt overlays. You can envision that the distance between the tire and the tack interface is much smaller for thin lifts than it is for typical lift thicknesses. That really increases that shear force created by vehicles during the turning and braking movements, as intersections and so forth. That is one of the several reasons why I really want to pay extra attention to make sure we have the best practices, the materials, and the construction practices when we tack in the preparation for a thin lift asphalt overlay. Furthermore, for tack, with this in mind, we want to focus on a few areas regarding tack in preparation for thin overlays. First, we want to make sure that the existing surface is clean as possible. The photo on the right on the top is a project where the laydown crew tacked the surface where still had a lot of surface dust. And you can see the results. The tack stuck to the dust instead of the roadway, and it really picked up the tack on the truck tires. Next, we want to make sure that we select the proper tack application for the product and the surface for which we are tacking. We want to make sure that the tack is applied uniformly across the surface. The bottom left-hand picture shows a project that is not only too low of an application rate, but is also not applied uniformly, or often referred to as fudge striping or zebra striping. The photo to the right of that shows just the right amount of application, the proper application applied uniformly, and that's what we're striving for. Managing your paver speed. Realize that when paving lift, each ton of the thin lift overlay goes a long way, and the paver can get down the road very quickly. Don't allow the paver to leave the roller behind, as shown here. Thin lifts cool very rapidly and need to be compacted more quicker than thicker lifts. And as you can see, he's way down there. You want to say, hello back there. Are you coming along? And again, with our traditional asphalt overlays, it's just the speeds are much quicker than it is for that. Next is mentioned by Robert. Material transfer devices are often used for placing these thin lifts of overlays. SMA or an open graded friction course are often placed using a material transfer device. Some examples: Oklahoma specification requires the use of an MTV when placing a premium mixture such as SMA or PFC, which is a permeable friction course, which Oklahoma normally uses a PG6828 binder. The MTV remixing capabilities help the contractor place the mat free of any physical and also thermal segregation, as we often see on our project. Rolling thin asphalt overlays. Be aware that rolling strategies will likely be different for thin asphalt overlays than compared to traditional. And the particular strategy will depend on the type of the thin lift. The normal compaction mode of thin lifts is in the static mode. For super pave or SMAs, you may be able to use the vibratory roller, but typically not. Check the mat for roughness and broken aggregates. If it's there, you want to immediately switch to that static rolling. You may be able to use the pneumatic on super pave as long as the mix is not so thin as to be damaging by the kneading action. Rolling thin asphalt overlays continuation. For open graded mixes, static rollers only are typically used. The mix should receive only 1 or 2 passes to properly seat the material on the roadway. The whole idea of an open graded mix is to allow that surface water to drain freely from the mix. So over compacting is very counterproductive. Pneumatic tire rollers can be problematic on gap graded and open graded mixtures due to their binder content, which can easily stick to the tires. The picture shows on the upper right of a mat permanently damaged because of the pick of a pneumatic tire roller. Next, on the QA/QC, one needs to determine the roadway density, as usually different for thin lifts. The problem is that it's difficult to separate that thin lift portion of a core and get an accurate, repeatable results from such a thin specimen, if you can even get a uniform core specimen to lift at all. If the thickness is at least 1 inch, thin lift nuclear gauges or electromagnetic gauges could be used. If it's 1 inch, the typical lower limits of these type of gauges can give accurate readings. Often the roller types and the roller patterns is simply agreed to and documented as a sole source of quality assurance. The inspector needs to document the roller types used, check the agreed about the number of passes being followed, and the project superintendent signs off on that will continue to be done while placing the thin lift. In addition, I wanted to share kind of one best practice. The Texas DOT has a water flow test that they use for thin overlays in lieu of density. They have established minimum and maximum flow times with their device, and depending on whether the mix is intended to be impermeable or permeable. Determining smoothness on asphalt overlays. The next and most important thing, because our customers like smooth roads, asphalt overlays will always make rough roads less, rough and smooth roads smoother. However, because thin asphalt overlays inherently increase the pavement thickness only minimally, increase in the smoothness are likely minimal. If a rough pavement is contracted to be overlaid with a single lift of asphalt, the owner should expect the same smoothness they might achieve on a multi-layer construction project. And lastly, The best way to improve smoothness on rough roads that are overlaid with a thin layer of asphalt is either mill the surface or place a leveling course first. And that's all. The next is I just leave it open for questions.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.